Good afternoon, everyone. My name is Elizabeth Guo, and I'm a current junior undergrad at Harvard University studying physics. I'm so excited today to be presenting my project on analyzing demographics and votes of the US Supreme Court. I developed and worked on this project last fall in a course on data science. I'll first start by describing the background and motivation of this project. The Supreme Court of the United States holds a really unique role in the United States government. Imbued with the task of exercising judicial review and interpreting the Constitution, how the Supreme Court rules on a variety of pertinent issues, gun rights, abortion, campaign finance, palpably affects the American public. However, in an AP National Constitution Center poll, 78% of respondents said they believe that justices let their partisan political views influence their actions, while only 19% believed justices decide only on legal analysis. And this is just one of many similar polls. So the upshot is that the justices in our nation's highest court might be perceived as nothing more than politicians in robes. This was the motivation of my project, to see, based on data, do Supreme Court justices vote predictably based on their demographic and political backgrounds? So now moving on to methods. I joined two data sets for this project. The first included demographic and political information for every court nominee. The second tracked each individual justice's vote on every Supreme Court case, including the vote direction, so a binary liberal or conservative. I then joined these two sets using a unique ID code for each justice so that in one row of my full data set, I had the demographic, political, and voting information of a single justice in a single case. Now I'll discuss the results and what I found. So I made a website to show my results visually using our Shiny app. So we'll just go here now. And here we are. So there are three main parts to my results, which are shown in these tabs here. In part one, for some contextual understanding, I looked at 6 different demographic and political characteristics and plotted the cumulative numbers of justices over time from 1789 up until 2018. So I'll walk through some of the main trends I observed here. First, for religion, we started off with only Protestant and Episcopalian justices, but throughout time, and especially recently, we've seen an increase in the numbers of Jewish and Roman Catholic justices. So this is all the way in 2018. For family economic status, justices have come mostly from upper class backgrounds, but throughout time, and especially in the last 50 years, we've seen a rise in the number of justices coming from the middle class, while the number of justices from lower class backgrounds have remained relatively few. For race, we've only had 3 non-white justices in total, so we can keep scrolling, and we can see them here at the end. So there have been 2 Black justices and 1 Hispanic justice. For home background, we can see that justices before 1900 largely came from rural backgrounds, but later on, the number of justices from small towns and urban areas began to rise. And by 2018, most justices had come from urban backgrounds. Here you can see the total number of justices affiliated with each political party, Democrat or Republican, over time. And this graph starts in the 1850s, since that's when the modern 2-party system began to be defined. So all the way to 2018. And finally, we can look at the number of justices in terms of the party of their nominating president over time, also Democrat or Republican. Now, in the second part of my project, I wanted to see if I could use machine learning to predict a justice's vote direction, liberal or conservative, in a Supreme Court case based on various or a combination of characteristics. So in each of the following 4 models, I ran a logistic regression, made a prediction for how a justice will vote using the model, and then compared this with the real data set to determine the accuracy of the model as well as the kappa values. And in this part of the project, I only looked at the years between 1948 and 2018 to avoid any confusion about the changing party ideologies. So model 1 used a logistic regression to see if a combination of 4 personal demographic factors, religion, family economic status, race, and home background, could predict a justice's vote direction. It turned out model 1 predicted correctly about 56% of the time and had a kappa value of about 12%, which meant that it was 12% better than a random guess would have been. So the accuracy was barely over a half and the kappa was quite low, making this not a very good predictive model. Model 2 looked at whether a justice's affiliated political party could predict vote direction, which seemed like the most direct political model. This model actually predicted correctly 57% of the time and was 15% better than a random guess would have been. Again, the accuracy is not great, but this was actually the most accurate model out of the 4 examined. Model 3 looked at whether the party of the president who nominated a justice could predict vote direction. The model predicted correctly 52% of the time and was only 6% better than a random guess. So this actually turned out to be the weakest model out of the 4. And then finally, Model 4 looked at whether a combination of all 6 of these factors could predict vote direction for a justice. This model predicted correctly 56% of the time and was 13% better than a random guess. And Model 4 turned out to be the second strongest model behind Model 2, party affiliation, which shows that throwing in more variables into a regression doesn't necessarily improve the model's ability to predict. So now, with this all in mind, let's move on to answering the question, are justices politicians in robes? The answer from this analysis is no. So here I plotted the regression for Model 2, which considered the justice's political party and was the best of the 4 models considered. So for the party of the justice at nomination, I coded Republican as 0 and Democratic as 1 on the x-axis. And for the vote direction, I coded conservative as 1 and liberal as 2 on the y-axis. So if justices always vote in party line, we would expect to see a concentration of points in the lower left and upper right quadrants and a line with positive slope. But this is not really the case. So as you click through the years, you can see that the slope of the logistic regression is quite flat in shape and only slightly positive. And there is a significant concentration of points in the upper left and lower right quadrants, showing that while justices do vote in party line more often than not, they are also voting out of party line here and here. And next is just a plot of all the data from 1949 to 2018 in aggregate. Again, slightly positive slope, but still a significant number of data points in the upper left and lower right, which is out of party line. Okay, so now returning to the slides, a discussion of next steps and possible explanations. The result that justices are not clearly politicians in robes might be surprising. One possible hypothesis to investigate next is, can we explain this as a matter of decision salience? So for instance, maybe it's the high profile cases that tend to be politically split, which is why we think politicians are so political. Maybe there are plenty of low profile cases that aren't so divided, and that's why none of my models were particularly accurate. Something else to consider is now, with the recent confirmation of Justice Amy Coney Barrett, how might the new 6-3 conservative liberal balance affect future data analysis? So, to summarize, this project has shown that justices are not very predictable in vote patterns, at least in models considering demographic and political background. They vote out of expected party line enough to disavow themselves of the stereotype of being politicians in robes. For next steps, I believe re-examining this analysis as new data comes in, as well as exploring possible hypotheses would be worthwhile. And that concludes my presentation. Thank you so much for listening.